This conference will now be recorded.
Okay, so just to recap, in the last session, we were understanding the workflow, right? On what exactly is the workflow in Terraform. So we understood what is Terraform init, validate, plan, and then based on any changes what you have, you will be doing the apply. And once the apply has been done, Terraform will track the status. So if you want to see the status, whatever Terraform is maintaining, then you can go ahead and say Terraform show. And if you want to destroy the entire infrastructure, whatever Terraform is taking care, then we should be doing a Terraform destroy. One second. Anyway, so over here, anytime if there is a change, then the Terraform plan will tell us on what is that change, and based on that, what is the new infrastructure that it is going to maintain. So for example, if only one resource has been modified, then it will clearly tell us what is getting updated or what is getting deleted or what is getting modified. Okay. Now for this, we also understood the first block what you're going to have in the Terraform file is the provider block, and then you would be having different resource blocks. Okay, so now for every resource you would be having a separate block, and this will be dependent on the type of the provider that we are taking. So this is where we need to first give what is the provider, and associated to it what are the different resource blocks that we have, and for each resource we have to give the value. Okay, so this is the basic that we were trying to understand, or the fundamentals that we were understanding. Okay, so when there is no change in the infrastructure what you have defined in the file or in the Terraform file, and if it is the same which is already available, then Terraform will say everything is up to date. So that is how only when there is a change, Terraform will go ahead and modify, or it will clearly tell you what are the things which are getting created or modified or deleted. Now, moving ahead with this basics, we'll now try to understand one of the topic called as taint. Okay, so what do you mean by taint? So here, so let's say when you run Terraform plan, so what happens? Terraform will read the configuration file and it will try to understand your desired state, and it will check what is there currently available in the actual infrastructure, and based on that it will tell you that okay, this is the infra you wanted and this is the infra currently available. Now in this, these are the resources that I'm going to create, or I'm going to update, or I'm going to delete. So whatever it is, it will clearly tell you. Suppose if Terraform finds out that the desired state what you have given in your configuration file is already available, then what happens? It will say everything is up to date. Okay, so that is where every time when you run Terraform plan, if there is no change, it will say up to date. Now there are certain scenarios in which if there is no change in the resource, but still you want the same resource or some other resources which is dependent on it to be forcibly recreated. Okay, what is it? When the resource is available and it is exactly the same what you want, Terraform will not say that it is going to get modified because it will say up to date. But under certain situations, if you want a particular resource or its dependent resource to forcibly recreate, okay, then by default Terraform will not do, because Terraform will just say everything is up to date. So in those kind of scenarios, when you want forcibly to recreate a resource, then you need to mark a particular resource as taint. Okay. So whenever you hear this word called taint in Terraform, taint means forcibly recreating a resource even when there is no change in the resource. Okay. Now, if there is a requirement, ourselves, we can mark a particular resource as taint, and on the next execution of Terraform plan and Terraform apply, the Terraform will forcibly recreate it. Okay, only on the immediate or the next consecutive Terraform plan and apply, Terraform will recreate. Okay, so this is where if we need explicitly to mark a resource to recreate. But there are many situations where when you run Terraform, Terraform itself will mark a particular resource as taint and it will recreate. Okay, so that is where there are scenarios when you have to explicitly mark the resource as taint, and then you need to do immediately a Terraform plan, and then followed by that Terraform apply. You will see that Terraform is trying to recreate the resource. But there are certain situations in which Terraform itself will mark it as taint and it will be recreating. Okay, so these kind of scenarios we will see, because you will be hearing this word called taint a lot of time. So to understand this, now let us try to create a resource and see how this taint is going to work. Like I said, by default, if there is no change, Terraform will not say anything. It will say everything is up to date. So that is where we can explicitly mark it as taint. Now, to get to this example, what we will do, so let's go back to our machine first. Okay, let me quickly start the machine. Okay, so let's connect to this machine. Okay, so this is a machine where we have our Docker and Terraform. And in this, all the examples I'm storing it into the Terraform folder. So the first example was Docker. So let me go to this folder here. Okay. Now in this, we created a file called main.tf. Okay. So let me edit the main.tf. So what do we have here? So we have a resource for creating Docker image, and we have a resource for creating a container based on the image. Okay, so quickly, just to go back from the beginning, Terraform, validate, Terraform plan. Okay, this time you can see it says two resources, that is the image and the container resource. And we are trying to create it because there is no resources available. Now this is where if I go ahead and say Terraform apply, okay, so it's here that there are two resources that we just now generated or Terraform generated. And to see the result, if I say Terraform show, you can see it is giving the details of the image ID, and the same way it will try to show you the container details also. All right, and corresponding to it, if I say Docker images, you should see there's a Nginx image and Docker PS, it's available. Okay, now this is where if I say Terraform plan, you should see it's saying it is up to date because in our configuration file, we have told we need a image and a particular container out of it. So both of them are available. Guru Kumar, can you mute yourself? Okay, thank you. So here there is no change, correct? Because everything is up to date. Now, this is where we will try to do this change. Okay, so let me edit this main.tf. Okay, now see what is happening here. I'm going to change the image name from Nginx to Apache. Okay, so logically, what is your expectation? So our expectation is I'm changing the image name, so the container that we have created should also be created, right? Now that is what we thinking, but logically there is no dependency between these two. So now after changing this, if I go ahead and say Terraform plan, what is happening? So do you see it is saying that only one resource is getting updated. Why? From whatever we have given in our state or the configuration file and what Terraform is running, exactly only there is a change in the image because container is already running, so it doesn't need to recreate, correct? So that's where it says only the image resource has to be recreated. But logically, I know that the container I created is based on the previous image. So if I have changed the image, I also want to recreate my container resource. Getting it? So this is a scenario where Terraform is not creating, but I want the container to be now forcibly recreated so that instead of running the container from Nginx, I want to now run the container from Apache. Okay, so just to show you again, if I go back, we'll take DNS. Hope it's running. So you can see Nginx is what we are running currently. And if I want to update, I don't want only the image resource to be updated. I also want the container resource also to be recreated. Okay, so in those scenarios where Terraform doesn't change, but you want to forcibly recreate a resource, then you have to mark it as taint. Okay, so to mark a resource as taint,
A
what you
question.
have to do, yes,
Which image is that Engine X running on right now, given that the image was removed or was changed?
we earlier had Nginx, but I updated in my configuration file to refer to a new image called Apache. So that is what Terraform is trying to tell. So obviously, now since we are changing the image from Nginx to Apache, I want to recreate the container based on the new image. So the new reference what we have is Apache. So the container that has to be recreated should be recreated from this.
When the image was changed, did that affect the container?
I didn't get your question.
When you change the image from Engine X image to HTTP, did that affect the container because
Just
the
now I
container
did.
was...
Just now I did, right? I edited this file
No,
and
I
just
know.
now
I'm
I
asking
changed
that.
it.
No, the container was already running, right? So when the change was made,
Yes,
did that affect the container?
container has not done the change. That is what we are trying to see. So we are trying to say that Terraform is not changing the container. So we will make it change. How do I make it change? So that is where if we mark the container resource as taint, and then if we do a Terraform plan and apply, Terraform will try to recreate the container resource also in addition with the image resource. So that
I
is what we are
understand that.
trying to do.
I understand that, but I was just asking if changing the image affected the container, because the container was already running on Engine X, right? Now that the image has been changed, what happens to the container at this point before doing the form apply?
Container will not get changed. That is what I'm saying here. So see, there are two resources. Now, container is still going to run the same because container doesn't have any dependency to the image. That is how we have written the configuration file. So when we change the image, only image is getting downloaded. The container doesn't get affected. But logically, that is what I'm saying. In this scenario, running a container and having an image are two separate things. So that is the reason if image change is there, it is trying to tell that. So regardless of whether I'm changing my image or not, container will still continue running because it has been created from an image earlier, which is from Nginx, and the Nginx image is still available on my machine, right? So as long as that is there, container will also run.
Okay.
Got it?
Yeah, good.
So here, how do you mark a resource taint? Now, this is where anytime if you want to identify a particular resource in Terraform, then you will be doing certain thing, which is you have to give the resource type, which is nothing but your provider underscore the resource type, okay, and followed by dot and the resource name. Okay, so this is what we call it as interpolation. So in that way, if you see in our configuration file, we were giving the same as name. So if you look at this, so this is the resource, right? So we have to say Terraform taint and the resource provider and the type is this, and what is the name of the resource that we have given, which is a unique name. So this is how among the resources that your configuration file has in the current directory, you are uniquely identifying a resource. Okay, so remember this resource type dot resource name. Okay, and now if I want to execute, so let's go back and I'm going to the same folder and we'll say Terraform taint. Okay, and you can see it says the resource has been marked as taint. So watch carefully. Now, if I go back and say Terraform plan, earlier it was showing you only one resource, correct? And now what does it say? So it's trying to say there is one resource which is getting updated, that is image from Nginx to Apache. However, you can see there is one resource which is getting recreated, that is destroyed and created, which is nothing but container. Okay, and this is where it says plus or minus, which is what I was trying to explain yesterday, right? So one resource is getting updated and one resource is getting recreated, that is destroy and then create. So that is how, since this has been marked as taint, you can see Terraform forcibly says that it has to be recreated. All right. So now if I go
So
ahead and say Terraform apply, yes,
yeah, so Nginx will be destroyed.
no, we are not
Sorry,
destroying
Nginx.
anything.
So
Container will be destroyed.
yeah, container, Nginx container.
Yes.
If we keep the both, then
We cannot keep both because at any time there is only one resource that we have to maintain. Okay, it says there is some issue, provider block issue. Okay, when expanding the plan for, okay, looks like Docker is not supporting it, but let's just cross check quickly what it has done. Okay, container it has not created. So let's run Terraform apply once again. Okay, so this time it created. So Terraform show. Yeah, there will be some changes in the version. Once again, don't worry about that. So we have our image, which is on Apache, and the container is also based on Apache. Okay, so Docker PS. Okay, you can see it's running from Apache. So now if I refresh the same, instead of Nginx, now the container what we have is Apache. So you should see it is working. Okay. Now the real-time exposure is the same. Okay, so you should be knowing that at certain situations, when there is some parent resource modified, even though there is a no change required, like I said, you might have to recreate a dependent resource forcibly. Okay, so let's assume that's what, to understand this, you also need to know certain dependencies. So what are the different resources? Like assume that there is a machine, okay, and corresponding to the machine, there is a separate storage available like a S3 object or a EBS volume, which you have attached separately. Now, whenever this machine there is application, now let's say that got crashed, now you don't want to use all the data or the logs what it has already stored in that storage like EBS volume or S3. Now when you are defining your Terraform configuration, there will be a separate resource block for the machine inside which you are running application, and there will be a separate resource block for your storage like S3 or EBS. So when you delete or try to modify something in your machine, the resource of machine is only getting modified. The storage will never ever get changed, or there could be some other changes that you want to like delete everything entirely in the storage like S3 or EBS will not happen. So in those kind of scenarios where logically I need to modify, but if you look at it explicitly, there is no such change required. It doesn't mean that if you recreate a machine, I also have to delete certain storage somewhere. So in those kind of cases, if you apply taint on that, so whatever the respective storage that you have, object, right? So that will also get forcibly recreated. So those are some of the scenarios where you might have to use. But this is one use case. Now, like I said, there is another use case as we move forward. Little later, we have different other concepts. At that time, we will see how Terraform itself will be applying this taint on the resources. Okay, so we have other concept called provisioners. So as we go towards the end, we will see that topic. So at that time, we will come back. But for now, just remember, anytime if you want to recreate a resource without a modification, without a change, that is forcibly, then you have to mark it as taint. Getting it?
Yeah.
Yep.
Okay. So as soon as you hear taint, so immediately you should be recalling this word. Okay, on the next or the immediate execution of Terraform plan and apply, we will be having the particular resource forcibly recreated. Okay, now what we will do, since we are just learning these things, now let's go back to AWS. Now I want to create a machine. Okay, so now let's get little bit into AWS. Now we're just seeing the example of Docker. So what if you want Terraform to connect to AWS and create a machine? Okay, so this is where we need to now give a separate resource block. Okay, so let's take this example. So in this example, if you see, there is a provider block. So that is AWS, and there is one more resource block in which we are giving a resource type specifically to this. So here we are creating a machine. Okay, and example is just a name for this resources to uniquely identify. Now for creating a machine in AWS, there are a lot of values that you have to give, but if you don't give them, there are a lot of default values which will be assuming. So that is where in this example, just to show you, all I'm trying to say is create a machine, or it is not creating a machine. So I am telling I need a machine to be available, and that machine should be created using some image, that is the AMI, and what is the type. So all the remaining things, it will be taking it as default. Like it will take only one machine. It will try to create the machine under the default VPC and default security group. And the same way, it will try to take the default storage. Okay, so I'm not interested to connect to this machine, but just to show you how Terraform works against AWS. Okay, so couple of things that we need to know in addition is, so when you are executing this, Terraform has to first download this provider, and then Terraform has to connect to the AWS. So to connect to AWS, we need to give the credentials, right? Now that's where whenever you want Terraform to connect to the credentials, so you need to give the credential. So if you are trying to give the credential, now either you can hard code it within this provider block using certain keys. But what will happen if you're adding a credential directly here, then that is not a good practice. This is because once you have written this, where are you going to store? So you're going to store it into GitLab. That is what is the first topic that we understood last week on continuous development, right? Anything you develop, store it into GitLab. Now, if I am taking care of production, and in the production, I want to run some Terraform, and for that, If I try to store my credentials directly into this block in the file and push it to GitLab, now anyone who has access to that can ideally see the credentials of production, right? So that is not correct. So one way you can store it here. Now there are a couple of other ways. Now, one of the way what you can do is you can set up what we call it as an environment variable, and we can use that environment variable to fetch it, so that when Terraform runs, Terraform will see if the values has been hard coded here, it will take. If not, it can also read from the environment variable. Okay. Now, how do you set the environment variable? Now, before we set the environment variable, you are not going to give the username and password like how you connected to the Terraform, sorry, the AWS console. Okay, so for any kind of programmatic access to AWS, you need to create a key which is called as access key and secret key unique to your account. So that is what you are going to use to connect to AWS, not your regular username and password or Gmail ID and password. Okay, so remember, programmatically, if you want to connect to AWS, so what do you mean by programmatically? You might write a shell script or a Python. That is programmatical. Using Terraform, it's also programmatically. Okay, you want Ansible to connect to AWS. That is programmatically. Okay, so any kind of automation through which you want to connect to AWS, then you need to generate that access key and secret key. Okay, so to do that, what you can do, go to your username. Okay, and in this, click on my security credentials. So go to access key. Now here, if you already have a key, you can use it. And suppose if you don't have a key, you can go ahead and create a new key. Okay. Okay, it's not allowing me to create. Let me delete these keys.
Hi, Adam. Actually, you logged into AWS through IAM member, right?
Sorry?
You logged into AWS console through IAM role, IAM user, right?
Yeah, root user.
Okay.
As root. So I'm just deleting all my old keys. Okay, I don't have any keys. So let me generate a new key. Okay, so what you have to do is make sure you download this key and keep it yourself. Okay, because once it is deleted, the password will not be visible for you. So if you download, it will be downloading a CSV file using which, or an Excel sheet using which you can open. If not, you can just quickly get that from here also. But make sure you copy this and store it somewhere. Okay, fine. This is one thing that you have to do. So going forward, if I want to connect to my account, then instead of using the email and password, I can use this, what we call it as the access key and secret key. Okay. Now this is the first thing that you're going to do. Generate the access key and secret key. Now what after this? So this is where you need to set an environment variable. Okay. So what you can do, you can create an environment variable on your machine, and this is how you are going to set. So now I can set my environment variable like this. Okay. Okay, now I can just run this. So the environment variable is set. when you run Terraform will try to read this. But just like someone was asking in the beginning, when I log out, this terminal will get disconnected and the shell will also not be there. So the environment variable will not be there. So every time when you log in, you need to set it. So instead of this, what you can do, you can go to your home directory, and under the home directory, there will be a file called bash rc. Okay, so that's what I'm trying to do. So I'm editing that file, and anywhere you want, you just add an entry. Okay, so always I'll do is go to the end. Okay, and here I will just add those 2 lines. So this way, every time I connect to the machine, I don't want to set this variable. Automatically, the environment variable will be set. Okay, so that is what we call it as login script. Okay, so now we are ready. So what we can do is we can try executing this. So let's copy paste. So let me go back. Now I don't want to do anything in that folder. So let me create a new folder called AWS. I'll go to this, and here I'll create a file called main.tf. Okay. We'll see the best practices at the end. I'll cover that. Okay, now how do you get this image ID? So once again, go back to AWS, EC2. Now when you launch a machine, you can see against the image, there will be some ID. Okay, so this is what you can pick, whatever the image that you want. Okay, so this is the ID that I have taken something similar. So I can take this. All right. Okay, so I have this. So now I'm saying Terraform to connect to Mumbai region, and in the Mumbai region, make sure that there is a machine available. Okay, so let's clear. And now to start with, we should say Terraform init, because this is the first time you do not have the plugins downloaded. So it'll go ahead and download. Okay, now everything is fine. So let's go ahead and say Terraform validate, Terraform plan. Okay, so it says there is one resource which is getting generated, and Terraform apply. All right, so it says it created, and now if I say Terraform show, you should get the entire details of this. Okay, so Terraform has created the machine. So at any time, if I do a Terraform plan again, it should say, I'm sorry. It should say that everything is up to date. Okay, so let's go back and refresh this. You can see two machines running. Okay, so this is the first machine, and this is the machine that we just now created. Okay, so you just tell Terraform what is the state you want, and that will create. And anytime, if I go back and say Terraform destroy, so in this current folder, the configuration file, whatever you have given, that is what it is going to destroy. So that way, only that machine, whatever it created, right? It will safely delete only that, not everything else. So whatever Terraform is managing, whatever that you have told in the state or the configuration file, that is what Terraform is going to handle. Okay, you can see it's going to delete only that machine. Okay.
So Adam, in this script, we did not mention the PAM key. So how will we be logging in this machine?
We can't log in. That's the reason I said it's just to show you to connect. We'll come back to a full example. Now, this is just to
Okay.
give you a logic on how it works. But yes, you need to add other keys so that, as you said, if you want to give a PEM file or associating key, then you should add the further key values inside this. Okay, but right now, just to show you how Terraform is creating and managing, for me, it's not needed. That's the reason
So
quickly I just showed this.
means we have to mention before running the script.
Yes.
Okay.
So you need to expand it fully. We will see that. Okay, so for now, you're just understanding how you will give a provider block for AWS and how a resource block will look. Okay, so that at least the connection part is what we have seen.
Yeah.
Adam, how did it
Okay.
got to know that it has
Yes.
to create in your AWS account? Like if I have to create in my
That is where we
AWS
are giving
account
this
an
key.
instance.
Yeah, that is what the
Okay.
access key that we have given. So when you run this provider block, there is no credential given, but if this environment variable is available, the Terraform provider for AWS knows that, so it will be reading from it. So whatever the account that you have given in this, exactly it is trying to connect to that. That is why we gave this credentials.
Okay.
Getting it?
Adam, the same
Yeah.
here also. One question here. You're exporting the
Mhm.
path, right? You're exporting the environment variable. So AWS access key ID, it is specific. We need to give this naming convention, or we can follow our own naming convention.
No, it's the standard. This is an environment variable which the provider needs. So you cannot change this. So it has to be exactly the same name.
Okay. So we can find it in the resource, right? This way names. So in order to remember every time.
Hmm? No, it has to be the same. You change your values, but this is how you have to create.
So,
This,
hello. Hello, Adam. Are you able to hear me? Hello.
Adam, I have one doubt. I think we lost him. Okay.
yeah, go ahead.
Yeah. In my environment,
Go ahead.
in my environment, we do have root access to all Linux servers. So in this case, suppose if we expose these credentials as a system admin, I'm able to access it, right? Because we are able to see all the files, right, from the server end.
Hello.
Adam, we can't hear you.
Am I audible to everyone?
Yeah, now
Yes,
now you are now we are
Now
here.
you're
We missed you for 1 minute.
Okay. Yeah, looks like some connection issue. Yeah, please go ahead, Palnivel. What was your question?
See, in my environment, I do have root access to all Linux servers. So suppose if any user is exporting these credentials in the machine, I can also take the credential and work on it, right? So there will be security issue come, right?
Yes.
Yeah.
Yeah, it is only one method. We also have different method, but ideally, are you going to take the root credentials for production? Then yes. So that is where it's not just one person who's going to work. So there will be different ways to manage, but yes, typically that's the whole concept of DevOps, what we are doing. So there might be multiple people that we are working, right? So having root credentials will not be a concern because we know who else has the access to the machine. So everyone should be responsible for that. But anyway, there's another way to do. This is just one method of working. But either way, if anyone has root credential, that means if you know Terraform and if you have root credentials, you have the ability to see. We can track who executed, why it was executed. So there will be questions coming, right? So it doesn't mean if you're executing it as root, not that no one can find out. We can easily find out who has root credentials. So why was this executed? So that way we can ask questions. But yeah, this is just one way for you to take it up as of now. Okay.
Okay. Okay, fine. Thanks.
Yeah, Adam,
Yeah. Thanks.
if we have more than one accounts of the AWS, how will we handle?
Yeah, I'll come back to it. That's what I said.
Okay.
We'll get into
Yeah.
those as best practice at the end. Let's not focus too much on that. So here, I want you to first understand the concepts in Terraform, and pretty much at the end, I'll cover up the best practice, right? So there we will see what are those difference, how do you manage. Anyway, this is just to show you now, you should have familiarity of what you mean by Terraform workflow and how does Terraform work against AWS. So you need a provider and you need a resource and you need credentials. Okay.
Adam, sorry.
Now this is where,
Hello.
yes.
Like Adam, can you hear me? Yeah, you said that this AWS access key ID and AWS secret access key as environment variable, right? Where we can find this variable name?
Where, yeah, you have to go through this provider
Okay.
document. So if you go to Terraform, AWS provider, there they would have mentioned it.
Okay. Thank you.
Yep. Okay, once again, the fundamentals is something that so far we have seen. Okay, so that, yeah, there is something called provider block, there is something called resource block, and you saw how Terraform runs and how Terraform picks up the state, and we know how do we maintain it, or how does Terraform maintains, right? So those, so far, that is what we just seen. Try to go through different topics. Okay. So the first topic that we have is called as dependencies. Now, what do you mean by dependency? So when you run Terraform, your configuration file can have multiple resources, correct? Now, in the beginning or in yesterday's session, I told you, Terraform generates a graph, and based on the graph, it has the intelligence to know what to run in parallel and what to run in sequential. Okay, so that is where, how does it know? So for all those things, we need to know how Terraform handles the dependencies between different resources. Okay. So to understand that, there are two types of dependencies in Terraform between the resources. Okay. So first rule, when you run Terraform, which is plan and apply, if there are resources and if there is no dependency between any resource, then Terraform will run all the resources in parallel. That is how the graph will be generated. Okay. So for example, you have a resource to create a machine. Okay. Now in AWS, for every machine, what will happen, the public IP will be kind of changing if you restart. So what you can do while creating a machine, you can specify elastic IP, which is nothing but a IP which will not get changed no matter how many times you reboot or restart your machine. So now the elastic IP itself is a separate resource. Okay. Now, if I'm trying to create a machine and if I'm trying to create a elastic IP, then there should be a dependency between it. Okay. The same way, if I want to create a S3 bucket, then a S3 bucket has a different resource. Now, if I want to create a machine and a S3 bucket both together, then what will happen? By default, if there is no dependency, then Terraform will go ahead and create both the resources in parallel. Okay, so that is how you can also save some time. Now, to understand this, what I'm saying, let's use that. So what I'm going to do, now,
Adam, your voice is not clear.
Adam, we can't hear you.
block, the credentials will be taken from the environment variable. There is a machine resource and there is a new block called AWS S3 bucket. Okay, so once again, this is unique to the provider block. Okay, am I audible to everyone?
Now
No,
audible.
no.
It's in the middle. You're interrupting actually because your voice has been completely got stopped while explaining S3 bucket, and your voice has been completely stopped.
We couldn't
Yeah,
hear for almost like
we
90,
lost you for about a
90
minute.
seconds something. Yeah, 90 seconds.
Okay, yeah, so what, let me repeat. So yeah, anyway, I'll repeat the same. So if you see in this example, you have a resource block for machine and there is a resource block for AWS S3 bucket. Okay, and this is a resource type which is specific to AWS. So once again, if you go to the AWS provider page in Terraform document, you will know what is the type. Okay, and the name here is example. So you can think that, oh, this is also example, this is like example. Now it doesn't matter, because when you're identifying a resource, you will always say the resource type dot resource name. Okay, so that is how it will be unique. Now, if you see this, I am trying to create a S3 bucket called as Vesva Adam Demo 3. Okay, now the resource what you have here and the resource what you have here doesn't have any dependency. So this is where when you run the Terraform plan using this, if Terraform has to create both the resources, both of the resources will get created in parallel. So that is what is the default behavior of Terraform. When there is no dependency, it will just go ahead and create both the resources in parallel. Okay, That's the first thing to remember. If no dependency, it will create in parallel. Okay, to show you that, now we have machine. Now let me open another page for the bucket. So there is no bucket created. So let's update our Terraform configuration with this and we will run. So what I'll do, I'll just copy this, go back to the example. So I edit the same file and I'll just add it. Okay. Now, whenever you're giving a name, you need to make sure that the name is unique, because same name, if someone else has created, then you will not be able to create. So you just have to change it to a unique name. So what I'll do is I'll change this to as what tech. All right. So now I don't have to do a Terraform init because it's already done in this folder. So the only thing that I have to do is start with Terraform validate and Terraform plan. So what is it saying? Two resources to be created, and what are those? One is the S3 bucket and the other one is machine. Okay, so this is the machine. Now watch carefully. When I say Terraform apply, you should see that both the machine resource as well as the bucket resource is going to get created parallel. Do you see this? Both of them are getting created in parallel. However, the bucket or the S3 bucket got created immediately, and it is still waiting for the machine to get completed. But the point here, what we saw was it created parallel. Okay, so note this difference. Both of them are getting creating immediately, that is in parallel. Just to cross check, refresh, you should see a new machine, and go back here, refresh, you should see a new bucket. Same way, if you do a Terraform destroy, what will happen? Both of them should get destroyed in parallel. Okay, now just watch this. You can see both the resource is getting destroyed or getting triggered to destroy parallel. Okay, so that is how, when you do not have a dependency, Terraform will try to create the resource or delete the resource in parallel. Okay, suppose if I had multiple resources like this, all those resources which doesn't have dependency will be created or destroyed in parallel. Okay, clear on that first? On how does it create parallel?
Yep.
Yes, Adam.
Okay, so now let's go back to our dependency. Okay, now this is where, if you want to give a dependency, so in Terraform there are two types of dependencies, implicit and explicit. So let's take the first one, that is implicit dependency. So what do you mean by implicit dependency? So if one resource depends on another resource value, then it is called as implicit dependency. That means for you to generate a resource, you need a value from another resource. Okay, that is what we call it as implicit dependency. So now when you are trying to run Terraform, if you want to read the values of one resource from another resource, then once again you need to use the interpolation, which is nothing but the resource type and then resource name. And this is where additionally we are going to say the attribute name, or what I'm talking about is the values. Okay, so what do you mean by attribute here? So when you try to create a Terraform resource, okay, you can see there are some values which are being generated, right? Like this. There are some values. Suppose, for example, if you take this machine, for this machine, when you do a Terraform show, this is what we would have seen. Now for this, what are the keys that you see? So these are called as attributes for this resource. So if a resource is generated, if you want to try to take a particular resource, then you need to know by doing a Terraform show, and you are going to get the attribute out of it. Okay, now this is where for any resource, if you want to take, so do a Terraform show and find out what are the attributes it is going to generate, and from this you are going to take this key. So this is called as attribute. For example, if I want the ID of the machine which it has generated, then we know the resource block. What we are going to give is resource type dot resource name dot attribute. So the attribute will be ID. So for example, if I go back, if I want to take the ID of this machine after it has created, if I say AWS instance dot example dot ID, then within the Terraform, you will get back the ID of this machine. Same way, just to put another example, assume I want the IP address of this machine. Okay, then this is my attribute name. So here, if I just say the same way, AWS instance dot example dot private key, then this will return me the value, which is nothing but the private IP, which is this. Okay, so this is how, when you are running Terraform, you can get the values or the attributes value from a resource. Okay, so this is where now what I'm trying to say here is, assume there is one resource which has been generated and it has some value, and when Terraform is going to generate another resource, then this resource can read the values from a previous resource. So that kind of dependency is called as implicit dependency. Okay, now when you put an implicit dependency, then first it needs to make sure that the parent resource is created, because if you want to read a value like this, then first the resource should be generated, right? Only when the resource is generated, you will get all these values, and from that I can create another resource. Okay, so this is where if one resource is going to read values from another resource, then it is called as implicit. Now to take the same example of elastic IP, okay, so see what happens now. So if I'm trying to have this, so this is implicit dependency. Now let me take the same provider block and let me add a new block. Okay, so now watch this. This block is going to create a resource called elastic IP. Okay, so this is the type of resource, and this is the name that I'm going to uniquely identify. So when I'm going to create a resource called elastic IP, I need to associate the machine for which the elastic IP is created. So that is where, when I'm saying this keyword called instance, I need to give the ID of the machine what I am going to generate. Now this is where, if you see, rather than hard coding it, the whole concept of Terraform here is this resource will anyhow generate the machine. So all you have to do is take the ID of that and pass it to this. Now that is where the value for this keyword in this resource block is actually referring to attributes value from another resource. And that is where you can see I am saying AWS instance dot example, which is the name dot ID. So now when Terraform reads this, Terraform will know that, okay, for me to create this resource, I need to read an attribute called ID from another resource. Okay, and this becomes a dependency. Now this is where, if I want to generate this, the first thing is the resource should be available. So logically what will happen now, Terraform will first create this resource, take this attribute and then replace it here, and then create this resource. So now there is a dependency. So when you start running resources, what will happen? In this case, what will be the first resource to get created? Machine, and then elastic IP. Why? Because elastic IP depends on this instance resource block, because there is an implicit dependency. So this is how one resource can depend on another resource. So when you try to run this, first machine will get created and then elastic IP will be created. Same way, when you try to destroy, what will get destroyed first? Elastic IP will get destroyed and then the machine will get destroyed. Okay, so that is how you can set up dependencies. Now watch this. So what I'll do, I'll edit the same. Now let the bucket be there. Along with that, what we will do, we will have one more resource. So we have totally 3 resources, right? Now, when I run, these 2 resources will get created parallel, but only after the machine is created, this resource will get executed or will get created. Okay, so that is how the dependencies will go. So let's execute this. So watch again, Terraform validate, Terraform plan. Okay, so altogether 3 resources. So just pay attention here. So you can see the machine and the bucket resource is getting created, but only after the S3 the instance is successfully created. You get a message like this, creation complete. Then you will see the elastic IP resource is generating, because the value or the attribute is needed from the machine resource. Okay, so just see that. Okay, so do you see in the end? It says that it needs the dependency over here, so that once the machine is complete, only then the ID will be generated, and then this resource is getting created. So now if you go to this machine, this is the newly created machine. So if you just scroll to the right, so this is the elastic IP that we have generated and we attached. Okay, So this is how you can specify implicit dependency. Same way, if I do a Terraform destroy, so see how does it get destroyed one by one. Okay, so this time Elastic IP is getting destroyed, but along with it, bucket is getting destroyed. Why? Because there is no dependency among them. So that is the reason while deleting, bucket and Elastic IP will get destroyed together. However, only after Elastic IP is destroyed, then because of the dependency. Okay. Now, this is the same logic which we also used in our Docker example. Okay. So if I go back to this, so here if you see, this is the image, and while creating the container, I need to tell the name of the image, correct? But instead of hard coding the name of the image, I'm trying to tell a implicit dependency. So this is where I'm telling go to a previous resource called Docker image dot my image, and in this there is an attribute called latest. So from that, whatever the ID you have, you replace it here. So that is how when you were running this, if you have not noted, we will see now, first image was getting generated, and then, sorry, first image was getting downloaded, and then container was getting created. So this was not running in parallel. This was running in sequence. Same way when you destroy, first container resource will get destroyed and then image resource. Okay. So watch this. Terraform plan. So we have two resources. Terraform apply. You can see first image. Only after the image resource is created, then it goes with the container. Same way, if I do a destroy, the container resource should get destroyed first, and then after it's successfully destroyed, then it goes ahead with your image. Okay, so this is what is called as implicit, which is nothing but one resource depends on a value or an attribute of another resource, is what we call it as implicit. So in this case, the parent will get executed first and then the dependency. Getting it?
Yeah.
So Adam, hello.
Yes.
So Adam, for every folder we are maintaining one main.ts file, right? TF file, right?
Yes.
So if there are multiple files and we want to execute explicitly one file, so how we can do that?
It's not like that. We'll get back into that concept a little later. So right now, let's have only one file, but I'll tell you what is it. But the logic, what you're saying is not possible. So Terraform will take all the configuration files available in a folder. So that is how you need to group all of them. So you need to know what file to keep, what name, and how to keep, right? That is where we will see it. So just for now, stick to main.tf.
Okay, Adam.
Okay. So now we saw how without a dependency, Terraform will run everything in parallel. We also saw how you can give implicit dependency. Now, the only last thing we need to know is how does the explicit dependency? What do you mean by explicit dependency? Now let's go back to this example. See, in Elastic IP needs the machine name or machine ID, that is where we gave this implicitly. So because of that, machine will get created first and then elastic IP. Okay, there is a logic, but now I'll tell you here. When I run this, both of them was created in parallel, but I want explicitly that there is a dependency between machine and bucket. Okay, that means, for example, same way like this, I want the bucket to be created only after the machine. Okay, now for this, there is nothing that the S3 bucket needs to know about machine, right? Because it's completely different. So in that case, I cannot use something like this. Okay, but still I want to explicitly tell a dependency, because even though there is no dependency between my bucket and the machine, but still I want to create it in sequence, wherein first I want to have a machine and then S3 bucket. So those kind of explicitly, if you want to have a dependency without giving any values, then the second type of dependency is there. Now for this, you are going to use a keyword called depends on. Okay, so here all you're going to do is take this. Okay, so you're going to use a keyword called depends on in any
Madam,
of
we
the
lost
resource
your screen.
and
I mean,
give. Am I audible? Hello.
Yes, Adam.
yes.
Yeah. Yes.
Okay, so what I'm saying, so wherever you want to set the dependency, you can go ahead and add this keyword called depends on. Okay, and then the value of this is not the attribute, but just the resource name. So that way, if, for example, my bucket is dependent on AWS resource, which is this one, then I can simply take this and say, so now what will happen? It is the resource type and the resource name. So now when Terraform reads this, it will understand, okay, looks like bucket is depending on another resource. So first, let me create that. So in this case, AWS machine will get created first, and then it will create the bucket. Okay, so such a kind of dependency in which we do not use the attribute or values from another resource, but we are kind of just explicitly telling that there is a dependency. Okay, so for explicit dependencies, you are going to use the keyword called depends on. So now see the same difference. For a minute, I'll just remove this elastic IP. Okay, and here I'll just add this. All right, so now when I run, see how is it different. So Terraform validate, Terraform plan. So what do you see first now? Here you can see that bucket is not at all displaying, because in the previous example, when I was trying to run in parallel without any dependency, that time you could have seen two lines, right? Instance creating, bucket creating. But right now there is a dependency. So only after instance is created, then you will see the bucket resource getting generated. Do you see? Only After this, your bucket is getting created. Same way, when I say Terraform destroy, first bucket resource should get destroyed and then the machine resource. See, getting the difference? So this is what is dependencies. Okay, so just to recall, remember you might be having multiple resources. Terraform will generate a graph by understanding all the resources. If there is any resources which doesn't have any dependency between them, all that resources will be generated in parallel. Then if you want to have a dependencies, then you can use the attribute of one resource into the other resource, then it becomes implicit. But without any attributes that you want to take, then explicitly you can tell the dependency using the keyword called depends on. Got it?
Say Adam.
Yes.
Adam, excuse me. Thanks. This is Matt here. Just want to acknowledge the fact that some of us are new to IT, and sometimes you explain that we're getting lost. Just doesn't know how this applies to us or how we can apply it in real life. For example, when you were talking about containers, creating containers, and then talking using hotels and all that, that was easy to grasp. But with these ones now, we're just having hard times getting just part and parcel of the things. Not quite. Is it able to bring it lower to the novices like us? Thank you.
Okay. So Matt, I think to get into a real example, it takes a little more time, but that is where what we are trying to see is we are trying to understand the concepts first. Okay. Because only when you know all the concepts, you will be able to put together everything and then you will be able to compare. Okay, because just by creating a machine we are not going to achieve anything, because every example we cannot do, but whatever I'm giving you is a real example, right? Because in real time you need to now know when do you create a machine and when do you create a bucket. If you know that, then while creating a bucket and while you're creating a machine, if there is a dependencies, that is where you will be thinking about implicit or explicit dependency. Okay, so you can't compare everything as a topic to real time in the beginning, but when we go to an example, so that is how you will be able to put all of them together. Okay, just to keep it on a lighter note, assume that I'm teaching you how to cook. Okay, now first I have to show you how do you clean your utensils, and then how do you wash your vegetables, how do you cut your vegetables, right? And then how much of salt or any spices that you have to put. Now, while explaining all of them, we cannot put everything that I'll show you a food, but maybe there are a few things we have to show separately, right? For you to show the cleaning of utensils, I just have to take only some dirty utensil, and then we just have to say, okay, now let's see what is cleaning. Okay, the same way, if you have to cut some vegetable, we are just going to see how to cut that. And then when we do some actual cooking, then we can say that, okay, now these are the steps you need. Okay, first step is you need to cut the vegetable and then you have to clean it, and then this is the process. So putting up together will be end, but instead of that, so what I'm trying to do is just to compare the same here. These are the topics. Okay, now which topic to use when, that depends on the use case, but that is where I'm keep repeating this point, right? For example, if I say taint, then immediately you should think on, okay, recreation. And now when I say dependency, then you should think of three dependencies. One is no dependency, which is parallel execution. Implicit dependency, where you will have the value from one resource to another resource. And then the third one is explicit dependency.
Okay.
For that, the example what we have seen. So if you run this and get used to it, keep this as one example. That's the reason I'm trying to take the examples as simple as possible. But later, if I try to show you one project in which I can take you taint, I can take you dependencies, and we will also take the entire workflow together. That is how things will be coming. But at that time, you should know, because in even an interview, questions will be like this. They will just say, okay, can you just tell me how will you write a Terraform file for which I have some 4 or 5 resources to be created? Can you just design and just tell me how? At that time, you need to start thinking everything. Okay, to achieve this, these are the resource blocks I need, and for this blocks, these are the dependencies I should have, or this is how I should be marking this as taint. I'm just saying an example with what we have covered so far. So that is how we should be able to take one by one. Okay, I understand what you're saying, but I would try to insist in this. Try to take the examples one by one that what we are giving and understand that particular concept with the example, get familiarized, look at the output and see how exactly it is behaving. And then as we move towards the end, when we know all of them, we will be able to put together, and which in different scenarios you will be having these things separately. Okay.
Okay, thank you.
Yep. Yeah, other than that, others clear so far on what do you mean by dependencies?
Yes, sir.
What type of dependencies are there?
Yes.
Yeah, yes, sir.
Okay. So now there are separate topics, as I said, right? So what we saw earlier was dependencies. Now let's take another topic called variables. Now first thing, what is a variable? Now whether it is Terraform or any kind of other scripting, right? You might have to reuse some values again and again, okay? Or you want to pass some values. Now for all those scenarios, it is not possible that you can always hard code a value, okay? So a variable, as it says, can store values or it can take a values during runtime. So this is when in Terraform, when you are trying to create some resource block. Now remember, we were trying to give a resource ID or what we call it as a bucket name, which is hard coded. Or for creating a AWS machine, I had hard coded the image ID. Okay. Now what if you want to reuse the same script? Then every time, instead of we going to the configuration file, editing it, changing the name, what we can do is we can think of using variables, which is nothing but instead of hard coding it, you can pass values dynamically. So for those kind of scenarios, we will be using this called as variable. So in general, variable is nothing but a place where Terraform stores some values which you can retrieve it and you can replace the value during a runtime. Now what I'm saying over here is this is the example. So take this example. Now you have a main.tf and you have this. Okay. Now what I'm telling you, okay, if when you run this, you are going to create a Ubuntu machine because this ID depends on Ubuntu 20, and you will create a bucket. What if I'm saying is, hey, can you create me another machine in which I want to create it from CentOS? Then you need to edit this. You need to change this value to some other value which is based on the CentOS machine ID, and then you have to run. Correct? So instead of that, if you want to dynamically change some values, then you should be thinking of using a variable. Okay, so instead of hard coding, you can create a variable and you can store the value, And the advantage of variable is, if you do not give a value, the default value will be taken. However, if I want, during runtime, I can change the values. So instead of hard coding, during the Terraform plan or Terraform apply, I can pass some values and I can tell Terraform what it should be taking. So that is how it is easy for us to reuse the content. Okay, because think on a very large perspective. Right now, I'm just using simple 2 blocks, right? But in real time, if you have 30-40 blocks, changing everything will not be a easy process. So that is where anything that you are developing, you should be able to reuse it. In that case, variables help us to reuse a code by just passing the values whatever you want. Okay, now when you are going to create a variable, in addition to these blocks, now we have a new block called variable block. Okay, so 2 blocks that we saw is provider, resource, right? Now additionally, we are also going to have a new block called as variable block. And when you are creating a variable, you need to have a variable block, and for that you will start with a keyword called variable, and then the name, and then inside that what are the values that you are going to give. And in Terraform there are different types of variable. Okay, so we will also see that. So to understand this example first, okay, let's go back to our Docker example. Now the reason I prefer Docker is it's simple to understand, but you can compare the same thing to AWS also. Okay, now go back to this. So if you take this example, how many values are hard coded? Image name, container name, the port, which is the container's port, and the host machine's port. There are 4 values which is hard coded. Okay, so now let us take the same example, and if I want just to make sure that any one of them is not hard coded. For example, what I'm saying, rather than running this and always Nginx will be created, I can pass a values of my choice. Now this is where what we can do. Okay, now let me just take the same example. Okay, so what I'll do, okay, I'll just take one by one and I'll show you. So first I will create a variable block. Okay, so now I'm defining a variable. You can give any name to it. So I'm just giving it as a string called image underscore name. Okay, and then there's a description. Now it's not mandatory, it's optional. And there is a default value, which is again not mandatory, optional. So whenever in the Terraform script, if you refer to this variable name, it will return you a value which is default called Nginx. Okay, so this way, let us complete our resource block. Now this is where when you are going to write your resource block, if you want to read a value from a variable, then you are going to refer the variable in this fashion. That is, you are going to say var dot variable name. Okay, and this will return the value of the variable. So in this example, if I say var dot image underscore name, at any time this will replace the value which is the default value Nginx, and that is what you can see I have mentioned here. Okay, so this way what will happen when I'm trying to run this, Terraform will replace this with the default value, whatever we have given. Okay. Now, I can have multiple variables also, but let's just try to take this and let's try with adding others one by one. So first we are just understanding what is variable, how do I create variable, because there could be multiple places at which this is referred. So wherever, instead of hard coding this value, if I just say var dot image name, it will just replace the value. Okay, so in that case, let's go back to Docker. Okay, so let's open this main.tf. Now I'll have all the remaining things the same way. Okay. All right. So this is what I want. So what I'll do, I'll just copy this. Now, I'm just hard coding all the remaining things, but let's do one by one. Okay, so you have a variable block and then an image block, and in the image name, it is going to take. Okay, so this is user defined. A variable is a standard key, just like how you have provider, resource, right? Variable is a standard, whereas the image underscore name is something I'm giving. So a user can give this. Okay. So now when I try to run this, what will be the image that Terraform will try to download? Nginx latest. Okay, because instead of hard coding, we are referring some value, so it can take. The same way, just to show you, for example, I can also say the same thing here, right? I can simply say where dot image underscore name. Okay. So now when I run this, Terraform validate, Terraform plan. Okay, now watch carefully. In the resource, what is it trying to create? It is trying to download the Nginx latest. How? Because it has reading the variable name here. Okay, so if I change the variable name, this will also get changed. Now that is where the advantage of variable now is you don't have to leave it by default, because when you do not tell anything, it will take the default values. But however, if you want, you can pass the values during runtime and change. Okay, so that is where you don't have to edit the main.tf again. So the whole concept, what we are trying to do with variable is, I don't want to hard code, and every time if I want to change, I don't want to change here. So if you put it as a variable, what will happen? If you do not pass anything, there is a default value that it will take. But however, if I want, then I can pass the value during runtime. Okay, so to show you that, okay, so you can see this is taking Nginx latest because the variable is getting replaced. Same time you come down, the container creation, it is the same name that it is taking. Why? It is a default value. So we have not given anything else, so the default value is being taken. So how do I pass a variable's value during runtime? So this is where, if you want to pass a variable name, then while you are calling Terraform, you can simply say -var the variable name and the value. Okay, so in this example, now when I do a Terraform plan, whatever is the value it takes. So the default value for this variable is Nginx latest. So that is where it took it. And now if you want to pass a value dynamically, so now when you're saying Terraform plan, you can say -var, what is the variable name? So image underscore name equal to whatever the value that you want. Now just to change, I'll say this as httpd latest. Okay, and now when you run this, Terraform will replace wherever this variable is there with the value that you have passed. So that way now the image will be downloaded based on this, and the container will be referring to this. So it will not take the default value. So the default value will get overwritten. So only when no one has passed the value, default value will come into picture. But if a user is passing it explicitly, then Terraform will take this and all the resources will be generated accordingly. So now watch this. Okay, just to show you, if I just do a Terraform plan, what has it taken? You can see it has taken Apache. So this is here. Without modifying my code, I'm trying to reuse it. So I can run it for different values. Okay. Same way, go up. Do you see the image name here is also referring? So that is how you can refer to a value which can be by default or it can be dynamically given. Okay. So now if I don't give this, whatever is the default value it takes, that is nginx. If I want, I can pass a variable and based on that it changes. Okay, so that is the benefit of taking variable. Now if I go ahead and do a plan, I get this, and now same way what will happen is when you are generating a plan in which you are passing some variable, and when you are trying to do the apply, so even for the apply you need to give the same variable. Okay, so for example, now I don't want to create the image and the container based on nginx, but I want Apache. Then anyway I just now did the plan, then I should also go ahead and say apply. Okay, and here what you can do, you can do auto approve. Okay, now it's trying to create parallel. Why? Because we have not given the dependency. Okay, so that's the reason you can see both are getting created in parallel. But anyway, docker ps, do you see it has created it from the Apache. Okay, so that is how when you are trying to pass a value, you need to pass it to the plan as well as you need to pass it to the apply also. Okay, and same thing when you are doing a destroy too, because every time you need to pass the value. If not, what will happen? Whatever is there in the default it will take. So that's the reason you need to remember when you are again doing a destroy, the destroy has to happen with respect to this value. Then it will exactly see the resource and it will destroy that resource. Okay, anyway, the image is still dependent on it. That's the reason it's saying force, but don't worry about it. So now you can see whether you are creating a resource or whether you are trying to destroy, you need to give. Now if you put that dependency, right, this will go away. Now since there is no dependency, container it is trying to delete it separately, but then on the other side it is saying that the image is trying to also delete in parallel. But before deleting the container, if you delete the image, what will happen? It says that there is a dependency, so that's the reason I'm not able to create not able to delete the image. If you put this dependency, that will work. Okay,
We
just
need
to
to
show
put it
you,
dependency, right?
I can do force, but let's not do that. Let's do a dependency. So docker image dot my image. So now when I run, definitely container will get deleted and only then image will get deleted, right? Because right now there is no dependency. So while container is getting deleted, image is also getting deleted. Because of that, it's giving an error that there is a container which is referred or which is using this image. So when it is using, you cannot delete the image. Okay, that is what the error that it was trying to say. But anyway, Terraform.
Dot latest.
Yep. Anyway, so now the same thing, let me do it quickly. If I don't give any value, it will take the default. So now if I want explicitly, if I say plan and the variable, so instead of taking the default, it will take the HTTP image that the value that you have given. Same way, when you apply, you need to apply with the same value. And post that, when you're destroying, you also need to give the same value. Okay. So if I say destroy, I can give the same value. So now you see there is no error because first container gets deleted and then image gets deleted. So this is how you can pass your own value to the variable. Okay. So instead of hard coding everything, you can pass. So Terraform, I can say apply, auto approve, and same way we can say Terraform destroy. So it's up to our choice. Okay, so this is how variables will be useful. Okay, now you can also pass multiple variables, so it's not just that one variable. Same way, while calling during runtime also you can pass multiple variables. Okay, now again, whatever the variable value you pass, only that will be changing. So should show you another example. Now here the port what we have, right? Now we can change that, or let me just change the container name. Now the container name here is just test ng. Now quickly what I can do, similar to this, I can create one more variable. So here I'll say container name. Okay, and the default value I'll just say no name. Okay, and now if I want to change this, I'll just say var dot container underscore name. Okay, so I can give this way. Now let me take this. Okay, so let's just run Terraform validate. Okay, what's the error? Line 23. Okay, this is where validate is important.
Please.
Docker image my. Okay. Spelling. Yeah, you just need to know what exactly you're giving. Okay, so let's just do a validate. Okay, now it's correct. So Terraform plan. Now, if I don't give anything, so the default name of the image is Nginx. Okay, and the default container name, what is it? No name. So that is how, if I want, I can leave it as it is. If not, I can say Terraform plan. Now I can choose. So it's not mandatory that if you have two variables, both of them has to be passed. So I can choose any one of them. Now, for example, I want only the image name should be changed. Then if I give this, while it is using your configuration, only the value that you're passing will get updated. So this is getting updated, whereas the container name is still no name. But right now, if I want, I can pass one more variable. So how do I pass? Same way. I can say -var. So the variable name is container underscore name and value. So let's say new container. So this is the name I'm giving, and I'm changing two variables. So based on that, your image is also getting changed. And if you go up, the name of the container is also getting changed. So that is how you choose what you want to pass, right? Now, if I don't want the image, I want only the container name, then I can just pass this variable. So whatever the variable that you pass, only that value will be changed. So you can see default is Nginx, it has taken, but the container name, it would change. So that is how, while you are executing your Terraform using the variable, we will be able to specify a default value, or you can also pass during runtime, which can be a single variable, or if you need, you can also have multiple variables passed. But just make sure that the same variable is what you are passing in plan, apply, and destroy. Getting it? So this is how variables will be useful, because the magnitude of the resources that we are going to create, right? There'll be huge 30-40 resources we will create, and your file itself will look 200-300 lines. So in that way, instead of hard coding values, you can create variables, and you can either leave the default value or substitute the values during runtime. So that is how your configuration file will be reused a lot of use cases. Okay, getting this?
Yes.
So whenever you see some values which you feel you want to change it, then immediately think of variable. Now, just to close today, this is just one way of passing a variable. Okay. However, what will happen is, assume this example. I have just two variables. Okay. So it was simple for me. I can pass it in this command. But what if you have multiple variables? Your command line itself will be too huge that you have to enter. Correct? So it will be difficult for us to run the command called Terraform plan with all variables, Terraform apply, Terraform destroy, right? So assume, what if I had 10 variables? So that is where this is one way of passing during the execution through the command line. If not, you can put all the values of the variable into a file, and you can just give the name of the file, and Terraform will just try to take that. Now for that, you need to have a variable parameter that you're going to pass called as -var file. So just in case, instead of passing like this, what you can do, I can just say Terraform -var -file. So instead of giving one single variable, you are telling Terraform to read from a file, and that file should always end with .tfvars. Okay, you can give any name, but it should end with .tfvars. So this way, what will happen? Terraform will try to read this variable file, and in this file, whatever the variables you have declared, it will take everything together. Okay, the same example, whatever that I have gave, all you have to do is inside the file, you create the entry line by line in terms of variable and the value. Okay, so this is the way that you should keep. So now, for example, if I want to pass this line by line, I can just say, if it is my container name, container underscore name, and what is the value? Okay, I'll just say new. So just see this. So I'll create a file.tfvars. Okay. So I have this on my current directory. So all I have to do is, while I'm calling, I just have to pass this. So this is taking from default, but let's go up. You can see the name is new. Okay, the same way, when I go ahead and say Terraform apply, you're going to do the same. Okay, so that's a difference. Instead of passing in the command line one by one, you can simply pass it as a file. Same way, you can say Terraform destroy. Okay, so instead of reading it from the command prompt, it will try to read it from the file. So this is more useful when you just have one variable or two variables that you have to pass. But when you have multiple variables that you have to pass, then go with this file method. Okay. So let me stop it here. So tomorrow we'll see different types of variables. But to just talk about the topic again, when you have a Terraform configuration file, there will be many resources and every resource needs some value. So instead of hard coding the value, you can set a default value using a variable, as well as you can also pass a value to a variable dynamically during runtime, for which you can pass it during the command line execution one by one, or you can put it into a file and pass that. Okay, so that is how we will also be using variables whenever it is needed. Okay, clear?
Yes, sir.
Yes, Adam.
Yes, Adam.